Hi, everyone, and welcome back to SPK and Associates vlogs, where we're trying to explore tools, strategies, and innovations around modern engineering practices and teams. My name is Michael Roberts. I'm Vice President of Sales and Marketing here at SPK and Associates. Today, we're getting into a topic that's a constant challenge for many engineering organizations, and that's managing large assemblies in CAD. Whether you're dealing with performance issues, long load times, version control chaos, large assemblies that end up becoming a bottleneck in your development process, hopefully we have some feedback for you today. I'm joined by Daniela. Daniela, feel free to introduce yourself.
Hi, everybody. I'm Daniela, and I am the CAD SME for SPK and Associates, focusing on all things CAD, such as SolidWorks and Creo.
And Daniela is a treat to be here today because I feel like she's experienced a lot of these types of challenges and has some real good insight. So let's get into what's really behind these large assembly problems and how your team can start maybe overcoming some of that. So Daniela, could you maybe start by explaining to the audience some of the common challenges and things that you see when managing large CAD assemblies?
Sure thing, Michael. One of the most popular I'll start off with is performance issues. So this usually manifests in slow loading times or saving and regeneration times. It can also show up as a laggy user interface when you're navigating your model or doing some rotating. And this is also earmarked by memory consumption. You'll note that this increases and this causes your system to crash, and there you are, you're stuck there. Um, Following up on that are complex assembly structures themselves and how to manage that. Um, when you have a small assembly with maybe 5 parts, managing that is pretty straightforward, but as you grow and manage hundreds or thousands of parts, that can cause some confusion. And even keeping track of those component relationships can be difficult. We often get the, why is this part modified? Oh, another engineer used it in their assembly and modified it to fit their work. Now it broke this other assembly that it was featured in. So when you have a lot of parts, especially parts that are commonly used by many engineers, this can cause some conflicts.
And we do have some customers that I know that you've worked with that have exactly the scenarios that you've talked about. So what strategies have you found most effective for optimizing performance of CAD systems and handling those large assemblies?
Sure. So when it comes to performance issues, I'll loop back to that. Utilizing lightweight modes is just key. And I think that's something that's so forgotten by engineers, or specifically people like vendors who are quality, who just need to open up this assembly, maybe do a check. They are not modifying. Um, just opening that up in lightweight mode can really save some time on your computer. Secondly, looking at your machine specs. I know when we get our machine, right, it's the latest and greatest, but depending on your IT department, those machines may not see the upgrades they may need. So doing a routine check of, hey, how's my machine doing? Do I need more RAM? Do I need a different graphics card? Things like that. It's good to audit. Um, and following up on the files that can get swapped out. I always encourage the use of a toolbox. So we've seen this quite a bit with McMaster car parts, for example, where one engineer grabs a screw, another engineer needs the exact same one and notices it's in the vault already. Perfect, I will use it. They modify it for whatever reason, and now because it was used elsewhere, that other assembly is now not the way it used to be. So I really do encourage using a toolbox where these parts are standardized. Users can't modify. So if they don't have the specific screw or washer they need, they'll talk to somebody to make sure that gets added. And in doing so, it won't affect subsequent assemblies that are using those files. So I have in fact seen that. And in fact, I know of a client who has many McMaster car screws, for example, and engineers are crafty, right? Oh, it's in there. Someone used it on their assembly. I learned from that. Let me add an _1. So now you have the same screw with different variations of the name used throughout. So I encourage the toolbox. That's the end there.
And I love that you mentioned checking the health of your machine. Do I need more memory kind of thing? We'll make sure we include a link to SPK VCAD, which I think is another maybe area to address for people that are engineers that are looking to have a little bit more horsepower in their machines pretty quickly without having to worry about IT spend too. So given what you talked about here, you haven't given any specific tools necessarily, but are there any specific tools or techniques that help maintain that system performance and integrity of those large CAD projects?
Sure. To delve a little bit deeper into the tool side, PDM system. Now, whether that is Windchill or SolidWorks PDM, this is heavily encouraged to maintain the integrity because you're able to see who is modifying what, when it was modified. You're not working on the same file an engineer somewhere else is working on, and oh, changes were overwritten. You have that control, which is great, especially when you're managing an assembly with thousands potentially of parts. You want to make sure they're all there, and even transporting, I say transporting, but sharing this assembly with somebody else can be very cumbersome because now you have this huge zip file. You don't know if they made changes when they send it back. Oh, they forgot this one file. Now you can't open. You're getting the suppress error messages. So it makes it so much cleaner because, I made this change in PDM, for example. When my quality engineer goes to open it, they will see exactly what I did, and I don't have to package everything up. I don't have to worry that am I getting exactly what I sent back to them. It erases so many of the issues that we see with sharing
Right.
files.
I love
When
it.
it Yeah, and it's great. It does so much more, but on that side, it's very helpful, especially if you're working with third-party vendors, folks who need to have the latest and greatest version. I can't tell you how many times I've seen the issue of, well, I thought this was the latest version, but this it was actually this version, and can you help us get the latest version in a PDF? So we can send it out because now we have to change it. And I've been on that receiving end of help us generate this when if it's in PDM, you're looking at the latest and greatest, and it erases just that little bit of doubt. So I will always plug a product data management system. Uh,
And and it's the smallest of things too, right? Like it's in most cases not a ton of investment just for the PDM component, and it provides so much value.
It really does. And also speaking to integrity, I know a few engineers who love OneDrive and love to store files there. Uh, the only thing I have seen with certain CAD softwares is it's a bit more prone to corruption. I have had this happen a number of times over the years where a user reaches out and says, "Hey, I can't open my assembly. Here's what I get." Um, and I ask to where these files are. They mention it's on OneDrive. I get the link. I also can't open. And I go through the steps right until I realize, oh, I think these are corrupt. Usually, for everybody listening, if you fear your files are corrupt, reach out to your reseller. They will confirm for you. Um, but it's a very bad news when I have to say to somebody whose files are only in OneDrive, they're corrupt. Do you have a backup somewhere? PDM provides that automatically. You can go one version down. You just have a few more options on the assembly side to diagnose that. Um, so for many reasons, I do recommend that, but integrity and version control are big there. And when it comes to performance, definitely using some of those lightweight modes. And I can't stress this enough because as an avid user, I'm not always the best at remembering, oh, this is very large. I might want to open it in lightweight, especially if I'm just taking a look at one specific piece. So you can look for this setting under your system options, assemblies, use large assembly mode. That will help load up some of these larger assemblies. For Creo, you can use shrink wrap to convert an assembly into a single lightweight part. That's another option for the Creo users out there. And what's really neat about Creo is you can run model check to validate some of the geometry and catch bloated features, kind of pare down that assembly if possible. And Creo also has a lightweight mode under options, assembly, lightweight graphics, reps. So there's options, but please don't forget as you're opening these large assemblies, you can do that in a bit more of an efficient way, especially if you're not editing.
We've had a couple other videos around large assemblies, and I think one of the ones was you said click open and then go walk away to get your coffee and come back an hour later. And that's so hopefully those recommendations will make it a little easier for you to keep working and not have to waste an hour waiting for a large assembly to open. Okay, so Daniela, I want to get to what I think is probably the most important. If you can maybe share a specific instance where you were able to successfully overcome a major hurdle in that large assembly management. If you could share that with the audience, that would be great.
Yeah, absolutely. The assembly in question wasn't the largest. It actually had about over 80 parts, which is sizable, but I know out there everybody who's listening can think of many larger assemblies they've worked with. So not the biggest, but it was highly detailed, which is something I didn't quite cover yet. Your assemblies can take a long time if they have multiple parts, but for my case, it had a very detailed linear pattern that was wrapped along a cylinder. This drove the rebuild time to be quite high, and it made collaboration really tricky. So I was sharing my screen and doing things with the team, and even trying to zoom in, my screen froze. I like to think my machine was suitable, and I did those checks, and still it was really painful to work on this model, especially when you're on a call, you're sharing your screen. Oh, you have to shut down SolidWorks because it froze, reopen it. It was rough. So the solution here that I found was a bit multifaceted. So not just one thing helped me out here. I finally identified, hey, the cause of the overhead here, it's not really the number of parts per se, but the detail, that linear pattern that was wrapped, it just really added to the load time. So I was able to isolate those pattern parts into separate subassemblies where possible. This helped me because if I did need to modify the pattern, I wasn't opening the entire assembly. I just focused on that one subassembly, which took some time still, but not nearly as much. And notably, it didn't crash my computer, so I was able to then share my screen and work with others. And I did also use a sketch-driven pattern, which I hadn't done that before. And then finally, I turned on large assembly mode and set those pattern parts to lightweight. So it's really great. This was in SolidWorks for our listeners here. I was able to set them to lightweight, so those parts didn't fully open to the full capacity, and that helped the loading time. So all these little things made it possible for me to work on this assembly when it was painful, and it led to no crashes. I was able to complete those changes and move on, and hopefully make it better for the next engineer, right? Because now they have those sub-assemblies and certain settings are in place. So that was my experience. I definitely have been on the receiving end of a either large or just very detailed model. So I feel everybody's pain out there.
Very cool. Thank you for sharing that, and thank you for sharing the whole deal here and giving us and our listeners more insights on how to deal with those large assemblies. So thank you for sharing that. For those of you watching, thanks for joining the video, and thanks again, Daniela, for sharing what you did so far. If you liked this video, be sure to like, comment, and subscribe on the SPK and Associates YouTube channel. And we look forward to seeing you again in the future. Thank you.